Yeah, hello. Bert and I here. We are today here to tell you some things about use cases of Hadoop in ING, a large international banking organization, although our headquarters is mainly in the Netherlands, but we are active in many other countries. We'll look at it from two different points of view, but about that later. Maybe first of all, I should say a few words about who I am. My name is Helmar Becker. I have been working for ING in the big data area in the department serving the customer intelligence departments for about 2 years now. Who am I? Well, I'm obviously, as you can hear by my accent, a German guy. But as it happens, about a bit more than 3 years ago, I went to the other end of the world, to the Philippines, and I met a wonderful woman there who was later to become my wife. And together we decided to set up our future and our family in the Netherlands. So we moved to the beautiful city of Utrecht, and that is when I started to work with ING in Amsterdam. Privately, I probably don't have a lot of hobbies because my main hobby is my family. What we like to do is, and you can see that here, so we have 4 wonderful children. This is the youngest one, and I'm here with him on one of our favorite activities, which is going to ancient places. This photo was actually taken on an ancient Roman aqueduct or water pipe in southern France, and it was just before the security guy came and said, "You're not supposed to do this." Yeah, so much about me. And the project I'm working at in ING is called Data Lake Foundation, and that is where the title Breaking Down Data Silos stems from. So the aim of our data lake architecture is to bring together all the operational and static data within the bank into one place that could be the source of truth, and that can be a provider for all kinds of consumers, be it classical business intelligence analytics, be it more modern advanced analytics in the direction of data analysts, but also data scientists, or what used to be called data mining. And also what comes in is lots of different data. So we have got the classical banking data that are batch processed still every 24 hours, but we've also got data that are much more dynamic, that come in from the mobile applications, that come in from all kinds of more modern data sources. And all that should be put together. And so the first point is to have a newer data platform. The second point is we want to do all this with open source software on commodity hardware because, well, it is, we see a much more dynamic development in that area these years, and it is a huge cost improvement also. Okay, so the data lake in itself is a very, very big umbrella term. I want to focus on one area of the data lake, and that is where we archive data. So basically, we take all the data that come from the input systems, from the systems of record, we bring them together in one format, and we store them in a place, in a way that is secure, both from manipulation, also secure from data loss, of course, and secure from unauthorized access, because we've also got customer data in there, which are sensitive data by European law. And as a banking institution, we need to be extra careful, and we really need to comply with all our regulations, or, as you could also put it, we have to earn and preserve the trust and the confidence of our customers. The data that are in this data lake archive will then be made available to the data consumers, as I said before. Why all this fuss? What we used to have was, well, this is a picture from circa 2000. Well, okay, I redrew it because well, you've probably seen this 1,000 times, but I drew it myself, so it's not copyrighted. So this is a classical data warehouse architecture. You see all these tons. So there's incoming data, which are in barrels, which means databases. There's an ETL layer, staging layers. The big data warehouse itself, which has a model layer and a real data layer. We've got data marts and we've got the consumers there. So this is a classical data warehouse model. It is very, very much tailored to the use of relational databases, because this is what people did 10, 15 years ago. And it was a cool thing back then, no doubt, but it has its shortcomings. One thing is, okay, we are in a relational database. That means we build a data model, and it is very difficult to change and adapt that data model after the fact. There have been attempts have been made, like Data Vault, which allow for more dynamicism. But it remains a fact that the relational database paradigm doesn't really cater very well to dynamically changing data models. Next thing, resilience, fault tolerance, high availability, data disaster recovery is all something that you can do with relational database systems, but it's kind of a pain and expensive, and sometimes it doesn't really work well. So we would also like to have something better there. Next thing, scaling. So we are now, when we talk about terabytes, petabytes of data, and I still remember those days when having 1 terabyte of data was really cool, and it was called big data back around like 2002. Nowadays, I go to MediaMarkt and I buy a 1 terabyte disk. It's just, now I cannot even buy a 1 terabyte anymore, because the minimum is like 2 or 3. Okay, so we cannot put these data to use on one single machine, so we need to scale. We need to scale out over several machines. And again, this is something that is handled less than optimally by these legacy systems. Okay, and number 4, now this is something that was cool about 1980, where you said, okay, I need to make sure that my data quality is always made sure by constraints in the database. So the database itself takes a lot of care of that the data in the database is okay, is compliant, is consistent. And that comes at a price. And we just simply cannot afford the price of that anymore, because if you want to verify a foreign key constraint over a petabyte of data, well, good luck with that. So there is, in the last years, a lot of products have emerged that address many of these issues. And this is where we are going. So we want to create this, we want to replace this architecture. But point is that we want to replace this architecture by something better. And this is what our architects drew up. This is what I affectionately call the slide with the many boxes. I stole this from our chief architect. Well, he approved that I use it. And this basically shows all the possible use cases within a data lake. So we've got the archive areas down here. We've got the classical warehouse here. We've got the more dynamic data in the operational status here. We've got all kinds of data sources. We've got the data miners and the dynamic modeling over here, the classical consumers here, and all kinds of data areas in here. So this is what we would like to have, but since we have all this infrastructure in place, all the legacy architecture in place, we cannot just rip it out and say, okay, we'll just all go to sleep for the next 2 years or 3 years while we are rebuilding everything. But we need to replace it one component at a time. And so the first thing, and that is what the team I'm currently in is doing is, you remember there was the ETL and staging area. Sorry, I can't do the animations right now. And we want to put a Hadoop-based solution there, which then can provide data to a still relational or more or less relational warehouse-based data warehouse. So what you see here, this here is basically a Netezza box by IBM, and this hosts all these classical barrels, and this is fed by a layer here, which collects the data, makes sure the data are complete, consistent, takes care of data quality, and keeps a copy of the original for the archive. And this will be based on Hadoop. So sounds like it's not a very exciting thing, just archiving files in a Hadoop cluster, but I think it is like planting a seed of this new technology inside an existing legacy. And it means that we have to just take this and connect it to all the legacy systems and data streams. And that is what is the exciting and also challenging part about our team. So we need to connect to a lot of existing systems. And in addition to that, we have all the challenges that we have in a bank. We cannot just say, okay, please give me a bunch of servers, give me a root password, and I will deploy a cluster. Well, the first thing is that somebody is going to say, you are not going to get the root password. And why is that? Number one is we are now modernizing our data centers as well. We are having data center as a service, infrastructure as a service. So we need to automate our deployments on top of that. So zero-touch deployment is what we should do. We also cannot just be admins because risk management needs to be done, risk mitigation. Everything needs to be audited. We need to comply with ING policies regarding access, regarding documentation, and we are facing little challenges like, okay, our infra guys are happy to deploy servers, but when we say, I need a cluster, then, oh yeah, what is a cluster? They can deploy servers that do not know of each other, and who makes the connection? Well, the infra guys, but okay, they currently don't have the process in place. So these things are going to be built. Another thing that many people out there probably don't think of is legacy protocols, legacy character sets, like, okay, so there's a mainframe, so we are going to do AppSedic. So all this needs to be connected, converted, so that it fits together. And above all, security is paramount. So security is a big thing of what we are doing right now. Well, luckily, we have a solution in place. So Hortonworks, which is our provider of choice for our Hadoop stack, also has a product that used to be called Access Secure. It is now used Ranger, and this gives us basically access control lists over all Hadoop services. Access itself, authorization, is handled by Kerberos, which is, well, I tend to call it a nerdy protocol because it is actually very, very nicely built in a very, very consistent and well thought out way, which is, however, utterly confusing if you are not used to the way of thinking of those guys that made Kerberos. So we are using Kerberos, but then if as soon as real users access the cluster, then again we come into the bank processes. We do not just want to maintain individual user accounts on a cluster, because what we want to have is access privileges that are automatically granted and revoked based on users' roles that have been set by the HR department or by any kind of other central authority. So Kerberos is going to be connected, and that is what we are doing, is connected to the corporate Active Directory in the background, where we get user information, we get role and group information, and also Ranger is connecting to the same database. So Ranger will then be viewing the Active Directory as an LDAP service. So these are 2 points of the three-pillar model of security. We have authentication with authorization. Number 3 is auditing. We can log every single access, and that's luckily also something that, that Ranger does for us. Little sideline thing or little sideline punch. Okay, so we talk to Active Directory. Is again a very, very nice, technically easy activity to connect this. But so we have Linux guys here and we've got Windows guys there. Normally they don't talk to each other. So to really get this to fly in a corporate organization also takes some time and effort and the help of many people. Yeah. This is how it looks like when you have the Ranger service. So here's you get a nice admin interface. You define your repositories, so certain parts of your data lake that will have access rights, and you can then set access rights, well, basically like an ACL, to individual groups or users, and that way it's all nicely organized. Yeah, next thing is we are working in an agile way. So also, while introducing a new technology, we are also introducing a new way of working. ING, like many other banks, comes from a more classical way of project organization, where you define your project goals in advance and then try to reassess it at the end. But Agile means you go back and iterate like every 2 weeks, for example. It also means you try to bring as many skills as possible together in one so-called DevOps team. That's another part of Agile. So we are doing that as far as possible. We would like to have even more of that, because at some point we still need to communicate across department boundaries, and that is where we sometimes get delays. So, and we also have a lot of attention, which is a good thing, but it's also a double-edged sword, because it also means that management is really looking very expectingly to us to deliver what should be their Christmas present or Easter present, or and so sometimes it makes me really sad to tell people that, oh yeah, well, there's another delay, but it sometimes happens. So managing expectations and managing external dependencies is actually quite a challenge here. But in the end, I hope it will all come out for the good. We are learning a lot. We are learning as we go, and well, we are sometimes really, it seems like we are bumping against some boundaries. Sometimes there are standards and procedures that don't really fit what we are doing, and the nice and deeply satisfying experience in that kind of work is that we notice that our own standards and the standards of the organization evolve also because we are relentlessly working the organization to do something about, yeah, let us make this work together. And that means we are, and that is, I really get the feeling, and it makes me kind of proud, that we are part of shaping the future, how we will work as a bank and give the best service to our customers. And that is really, well, for me it's being part of an exciting journey, and that's just great. Yeah, I think that's it. One thing, we are also sponsoring this event. There is one of my colleagues, Rob, is down there at the stand at the exhibitors room, and we are also hiring. We are looking for interested engineers, both possible employees but also contractors that are willing to work in the so-called big data advanced analytics sector in the widest sense, be it Hadoop engineers, be it data scientists, be it Cassandra, Spark, you name it. And I think it is a chance to be part of a really exciting journey. Thank you, and I'll hand over to Bart.
Yes. Well, thank you, Helmar. We brought this talk together in that Helmar provides us with the starting of the data lake where all the data will be housed. I'm more on the analytics side, using the data that's going to be in the data lake. But I'll tell a little bit of a story of how we got started, and I think what Helmar is doing is a continuation of how we started with Hadoop within ING. And I'll say a little bit about what went well and what didn't go well. I'm currently, it's a little bit of a different slide. I'm currently in Germany, so we have a German working in the Netherlands, and we have the Dutch guy going to Germany to work there. And I'm there kind of the same function as Helmar is, and we're setting up a new analytics team, and I'm the technical lead for that. A little bit about me, like I said, I lived in Amsterdam, worked at ING there, and then I took my boat, well, usually on the canals, but one day I took it up the Rhine and went to Frankfurt. So that's where I'm working now at ING DIBA, which is the German branch of ING. This is a little bit of the story of Hadoop within ING in the Netherlands. Last year already, my then boss, Anurag, who's also giving a talk after us in a different room, he gave a little bit of an update for the first 2 steps, and we can now take it one step further. So in 2013, we started with what we call the test lab. It was hardware that wasn't being used anymore. It was outside of the normal network. It was really a place for testing hardware. We brought our hardware there, set up a Hadoop cluster, and tested it. So to create awareness, to show what it can do, to show our first small use case. Based on that, in 2014, we built the first production Hadoop cluster within ING, also for the purpose of doing data science and doing data analytics. So that was the first milestone, and now what you see in 2015, part of it is building the data lake, but also making this analytical capability part of the data lake. So that will be going on for the coming time. 2013 is way too far back, but I'll tell you something about what we did in 2014. So this is our environment. We set up this first production environment for ING within the Netherlands, including all security and everything. We did data science on it. It's actually such a success that we're now growing and expanding. Most of the software we're using, we're using the Hortonworks stack. Data scientists, it's still, we're a bank, we have a lot of data warehouses. Those are also usually our source of data. Not always, but usually our source of data. So Hive is quite important to have our tables and to have data scientists work with that. And then there are preferred tools of use, Python, R, and they're now experimenting and working with Spark, trying that out, seeing how it works. Spark is often used for network analysis, I would say. And the hardware we have, it's a moderate cluster, I would say. We have 3 masters, 15 workers. Each of them has 15 cores, 64 gigabytes of memory, and 15 2-terabyte disks. This is a little bit less than what you would expect. You would expect 16 cores and 46 gigabytes of memory, but that's because we're in a big bank and we only get VMware, so the hypervisor takes a little bit away from what we would like to get. A little bit more about how we do this data science. We have data scientists that are part of the data science team. The business comes up with questions. Can you help us predict this? Can you be more accurate at seeing fraud or call center routing, or you name it? There's a lot of things we have to do. If there's a good business case, we put up a project team with 1 or 2 data scientists, 1 or 2 business experts, and a project manager. So it's somewhere between 3 and 6 people usually on a team. And they go out into the business for 3 months and quickly iterate and get some value out of that with such a team. And the hardware, that's the clustered environment that they use to do their data science. Yes? Oh, that went too quick. No, that one. This is a little bit the picture we have, the architectural picture overview of what our cluster and our exploration environment looks like. Let's start at the top, at the head. That is our data scientist. He isn't allowed to directly touch the data, so in between there is a virtual desktop, a Citrix. That's for security reasons, so they cannot directly get the data into their workstation. That is a Windows-based solution, so we want to go into a Linux-based solution, so then they have another virtual desktop into a stepping stone inside of the cluster. Next to it is our main data source, that's the data warehouse. We're connected to a data warehouse, so we get daily updates of files we find interesting. It's all file-based. And if there's a new project and there needs to be an initial load, it's usually some manual data to get the data sets and to put them in the pipe, and then they end up in the cluster we write the script that puts it in HDFS and Hive, and data scientists can use it. On the right, we have our security. So we have LDAP on a Linux level, so not like Helmar at the Active Directory, but we're at the Linux level, we do our security. So we get from central, based on your business role, we have certain users and groups that get access to the data. Monitoring, everything we do is monitored, and every once in a while we get an email, what were you doing, explain this. So that's all working. And totally on the left of the picture is how we develop. We call it the build server. It's a little bit of a misnomer, but we have Git, we have Jenkins. We store our artifacts there. Red Hat Python packages. Every week, I would say, a data scientist comes up with a new package and a new paper they've read, so they want something new. Originally, the idea was we connect this to the internet. Security reasons made that not happen. So there's a lot of manual work to load packages or dependencies that they need through the build server into the cluster and deploy it for the data scientists. So security, there's a few things. One I already talked about, the Citrix server. That's our glass window concept. You're allowed to look at the data, but you're not allowed to get it out and hold it in your hands. The other one is the data black hole. Data is allowed to go in, but never to go out. So data goes there to die. And the idea is what goes out is our algorithms, our models, but not the data itself. That has to go to, well, in the future, the data lake, for instance. That's where the data will flow and the models will run there. And last, we don't have Kerberos, but we do have big firewalls, like you saw in the picture, around our cluster. So that is our security level. This is also because we have, let's say, 10 data scientists, 5 data engineers. So the impact is quite low with the amount of people that have access to the data. So to actually have Kerberos was too much effort for this amount of people. In the future, we will have to do it when we have more people using the cluster. Our users come from Linux, from the central system, because we don't use Kerberos. It's limited set, and we do have, let's say, 2 duties. One is the data engineer to get the data into the cluster to make sure that the data scientists can work, and you have the data scientists that actually do the work, that get their hands into the data. And last, for security, we monitor everything. So what went wrong in this picture I showed you? A few things. So one is the obvious drawing in the architecture is that we have a double remote desktop. You get mouse lag. It just isn't a nice way to work. So in the future, this is definitely something we're looking at to replace with one solution. But that's, again, pick your battles, and we haven't picked this battle right now. The next one, this wasn't as clear in the picture maybe, but we have our 3 masters, and 1 master is misused as a stepping stone and also as a data ingestion area. So we have Zookeeper running on there, we have some other Hadoop services running on there, plus we have 15 people with a full desktop environment on there, plus we have data flowing through it, and that's too much to separate out. So definitely I would say keep all your users in one location and not let them touch your clean system, and keep that nice and clean and scripted. The other thing, as ever with us, is root access. You would say, why do you want root access? You can just sudo and that would be fine. Yes, sudo would normally be fine, but we live in an environment where our sudo is replaced because of security reasons. So we have a box, or Fox Secure, I think it's called, a Swedish company, and they replace SSH, they replace sudo. So all your scripts that normally would say, well, we don't need to have root, we just sudo and then we can do something, they don't work.
It's not even compatible, that's the...
Yes, we just don't have sudo on the machines. The next one is also an obvious one, I would say, that the data scientists are quite dependent on the engineers. They're dependent for packages on the engineers, and they're dependent for their initial data load. So that's also something we're building now, more of a self-service architecture where the data scientists can request certain data and it will be loaded for them instead of having this manual initial load. But that is all development that's going on and wasn't in place at the first moment. The last one, that the data black hole concept is too strict. It is too strict for now, I would say. We don't have a data lake to run our models in once we have it. So now we're in an intermediate phase where a data scientist has found something, they have a model, or they want to show something, and what to do next. You would want to run it on a prediction system, but it doesn't have the compute power of Hadoop, or it's a system that has a little bit of a different data set. So then the question arises, well, why don't we just calculate it inside of the cluster and export the data that comes out? But that's not incompatible with our data black hole concept. So that's also a maturity where we need to grow, and with the concept of the data lake, that will definitely help there. And the last thing, this is also related with that, like I said, moving something that is built inside of one environment to move it to a next environment is quite difficult, and sometimes it even requires full recoding. That might also be because the use case is different. So for instance, if you have any kind of real-time system going on, you can definitely do the data science in a batch mode to do back testing to see how it works. But then once you want to implement it, it's a real-time system and you have totally different requirements. So that's also why this path is not always clear and easy. We also did a few things right, I would say. One of the things that definitely works with data scientists is flexibility. Give them as much flexibility as they can. As soon as you give them a good tool for them, they will learn it, they will be experts at it, and it's definitely been more than once that we've installed something on the cluster or we've given a package, and within 1 or 2 weeks we've seen tangible results from data scientists that are asking you questions you didn't even think about when you gave them this tool. So flexibility in giving them what they want really helps. With that, a supporting team of DevOps to quickly give them what they want helps. So working in Agile Scrum, that worked out quite well for us. Automate, so everything we do, the initial deployment, we automate mostly with Ansible, but also all the data loads or all the package loads that are required afterwards. We try to automate that as much as possible so that the next time someone comes by, it's a lot less hassle than the first time. And I think, as Mike said in his keynote, just start somewhere, be the rebels, maybe we were the rebels, and things will grow from there. You have to have this grain that starts, and things will pick up from there. Last, for the sizing, I think this is a rule we came up with of how much resources does a data scientist actually need. So we saw in our cluster that a data scientist needs between 20 and 25 cores, between 20 and 25 disks. We have those 2 terabyte disks, but it's more about the disk than about the size, I would say, for speed. And 8 to 100 gigabytes of memory, which is okay for Hadoop MapReduce. Once you go into the Spark world, you are actually at 4 gigabytes per core, which is a bit low. So that might actually already be higher if you go in memory. So, what's in the future? Well, part of it is what Helmar is doing, having our place within this picture of boxes that Helmar showed, doing the data lake integration, and really being a part of this ecosystem of data within the bank, where exploration and analytics is different than the traditional data warehouse, because you want to be more direct on the data, have more capabilities, have more freedom. So that is one thing we're working on. The second one is multi-tenancy. As I said, we send out our data scientists into the bank, and usually after 1 or 2 projects, we have educated those departments. There's 1 or 2 people that also want access, and so the demand for access to the environment grows. And that means that we do have to set up multi-tenancy, we do have to set up Kerberos, we do have to say exactly who is allowed where and who is allowed to do what. So that's next. The other one is, as a stopgap between the data lake and what we have now at no data going out, is our visualization server to at least show your results with people within your team even you're working with, because not all team members are allowed on this cluster. So to have a place to show our results, to have a secured way to say who is allowed to see there, what data is allowed to go there, have a process around that, but have somewhere to go with our end results. And the last one is our hardware partner discontinued the hardware stack that we're on, so we need to have new boxes coming in, and with that we're also making the cluster bigger. So that means, well, almost a rebuild of the cluster, because on the one hand we're doubling the capacity and you're replacing nodes, so that's, well, let's just say we're rebuilding the cluster there. However, this is for the Dutch cluster that I worked with for the last year. For me, I've moved to Frankfurt and not to be part of the Dutch team. I'm now part of the advanced analytics team that's based both in Amsterdam and in Frankfurt, and we are an ING group function, which means that we help countries and business units for the whole of ING. So Belgium, the Netherlands, Germany, Romania, Turkey, Australia. For now we keep it to Europe, but our goal is to be the center of expertise to help the business units advance in their analytic skills, to have experts in data science and big data together to do these use cases, to experiment, to do fundamental research of how do you do certain things, can we speed things up that we see we repeat a lot, but also to become domain experts, to say we've been in this country and for fraud this worked well, so let's do that in another country too, or like the call center routing worked well here, so let's also implement it there. We are then the center of expertise, and we're there again with our data scientists to do use cases and to transfer knowledge that way, and to also do other knowledge transfer sessions. And with that comes a new international environment, not only for Dutch data, but for international data to land somewhere to do data science again, within the framework of the European laws, what is allowed, what isn't allowed. So we're now also in Germany building a new environment, and I'm the lead for making sure that happens. So that is in my future. Thank you all very much. I think we are now open for questions, and while we do that, I will show you where our pictures came from. So thank you very much. Any questions?
I have one.
Okay, well let's...
So what do you do for data processing, pre-processing and data pipelines? Not produce or?
It's whatever the data scientist uses. So the normal pipeline is, say, we have already a table in a data warehouse. So yeah, so the question was, what do we do as a data pipeline? The normal way for the data scientist is, it's usually a Hive table we make for them. So we actually extract from a database the metadata. We use that to create a new Hive table, import it into Hive. The data scientist goes away and creates 10 more tables based on this raw table. And in the end they say, well, we have found something and then we need to use this and this and this exact table. And then if it needs to be productized, it's built again by DevOps engineers. Yeah.
There was another question in the back.
A question in the back, yes. Yes, so the first question is, did you try Nox?
Yes.
The answer is no.
Well,
Okay, and the second one, sorry.
I can also...
Yeah, so I will also say why, and then Helmer will say something about Nox. So no, because the data scientists want to be right on top of the data. And Nox is only web-based, and that is too much overhead. They want to have a command line where they can do Python or an IPython notebook or our server that can directly connect with the data. So having this web-based API in between is too much hassle for them to program.
Yeah, and from our perspective, so from the Data Lake Foundation archive perspective, we've also been looking at Nox, but we believe that Nox may, if we really ingest large amounts of data and everything has to go through one single point of access, that we may run into scalability issues. That is why for now we have decided not to use Nox.
Thank you. And if another one, if I may, you said you're using Active Directory. I read blog posts saying that Hadoop could be a DDoS maker on Active Directory. Now there are new posts saying the contrary. What did you encounter difficulties with using your enterprise ID?
Can you repeat what was the problem with AD?
The problem is that Hadoop nodes, Hadoop query-based nodes, when starting up, can make downtime on Active Directory, on the enterprise Active Directory, if not sized properly, and that it can have consequences on the overall enterprise Active Directory.
Well, we are currently still building this, so we hadn't actually dared yet to connect it to the production Active Directory. So what I'm saying now has to be used with caution. We have, however, identified a potential risk, and that is that when we are synchronizing our users and groups into Ranger, then the default mechanism of querying the LDAP service that is behind Active Directory is not very smart. So it would just basically, it would slurp in the entire content of the Active Directory. And if you do that every 5 minutes, then I can imagine that your Active Directory is not happy. We are currently working on a way to improve this.
And I know we yesterday actually had a talk with some Polish colleague that said that they, for this specific reason, have made some code changes to only import a specific group within the Active Directory and not to scan the whole Active Directory. Because if you look at the whole corporate ING Active Directory, that's tens of thousands of users, I would say. So that's too large to load as a whole. But we see that as an issue, yes.
How do you transform and transfer data from the mainframe to Hadoop?
We have a homegrown software that collects these data. So, well, first of all, we have a non-standard transfer protocol that collects all data on a standard Linux staging machine. Then we have our own proprietary software that checks these data for consistency, that also does the character set alignment and makes sure that everything is in the right format. So that is how we do it currently. It might change in the future.
Another question.
Oops. That was a bad idea. Just wondering, so you're setting up 2 different Hadoop clusters for different purposes in the company?
No, more than 2.
Yeah. But is there any, because in the first presentation you said the data lake was supposed to be the first seed to see, to look for other purposes as well. But it sounds at the same time as if Bart is already using it for the purposes you have in mind as well. Is there any idea of merging this in the future? Or?
We've always been a little bit of an outsider. You only do data analytics. It's a really secured environment. Nothing else can happen. So I would say the data lake is, and what Helmar's doing is a way to break out of it and do it as a full company function where data actually flows through the system and doesn't go there to die.
And in the future, maybe you'll be one of the consumers.
Yes, definitely. That's
part of the story.
Yes.
So, I mean, it all started like 2 years ago. There was a team that set up something in a completely disparate lab, completely disconnected from anything ING. Then there was the team that Bart used to work with, which has this kind of glass window environment. And now then the Data Lake Foundation, where we say we really need to make all the connections.
Yes. Thank you all very much. I've just been informed that this was it. So thank you all for your attention. If you have any questions, please find us after. We're happy to answer.